All right, so we're here with Adam Kreidels, and we're talking about clean architecture. You may have heard of Uncle Bob. Uncle Bob, very famous for coming up with clean architecture. And what we kind of need to know is, what is clean architecture? So Adam, take it away.
What is clean architecture?
Yes.
Clean architecture is an approach to software engineering that emphasizes a separation of concerns. So you'll have heard of terms like coupling, so low coupling and high cohesion, to create a system that is more easily, or the intention is it's more easily evolvable, cheaper to evolve and change over time. So it's a combination of some really good approaches to software design and software engineering that have come before it. And Uncle Bob's packaged these into a nice little package that he calls clean architecture.
And we covered some of these last time. What are we planning on covering this time that's different to last time?
Well, I think last time we forgot to actually find out what clean architecture was and get into the deeper details about, like, what's a use case? What would a worker do? What's an interactor? What are some of the details? We talked about why you want these things, but we didn't talk about what they are.
Right.
So,
okay.
Adam, you just mentioned a few things, and I want to drill into those. You said separation of concerns. What does that mean to someone who's first day on the job?
So separation of concerns is focused around singleness of purpose. I guess it's separating out things that don't need to be together and keeping those things that do need to be together. And when we say need to be together, we typically define this as things that change together, should stay together. And if you were to think about that at maybe a slightly higher level, you're separating out things like your core business logic from perhaps your delivery system, or separating out your caching rules from the actual querying aspects of your persistence layer. It's separating out those pieces so that you can evolve them independently. Alongside, it makes testing easier. Hopefully, it makes any changes we need to make easier. It's easier to locate. It's easier to reason about. It's easier to talk about. That's how I'd. Probably not the best summary, but that's how I would summarize it, yeah.
It reminds me of, I was watching an episode of Mad Men yesterday, and they all work in advertisement, but they're very strict bosses. And one of the guys who works at the company has a hobby where he likes to write books, and the boss found out, and he's like, no, you can't do that. This is your job. You have no hobbies. You have to do this job really well. It made me think of singleness of purpose. It's just do one thing really well.
I'm a big fan of doing things really well. I don't like doing things if I'm not good at them, but I wouldn't say there's one thing I do really well. I'd hopefully say there's multiple things I do really well.
No, not an advertisement.
Okay.
Yeah. So what are some practical examples of single? I mean, you just do caching or something like that, but what are some examples?
Well, let's talk about clean architecture, and maybe let's start at a top level, and we'll hopefully this will put it into place a little bit for everybody. But if we think about single responsibility and separation of concerns, I think at a very high level, what clean architecture is about is focusing. It's a domain-centric design pattern. So I say domain-centric. It's putting your business rules at the center. And I think maybe one of the simplest way I'd explain that is when you're creating a new solution to a particular problem, where do you start? And I've certainly worked in places, and I myself have done this as well. Like I might start at, defining the API, or perhaps even worse, defining the database model. When the reality is, where's the value of our system and our solution? It's the business logic. So this is an approach where we should start with the business logic, and that should be the key aspect of what we focus on. So we reduce the number of dependencies. We keep that business logic as clean, as separated from those other details that might change for different reasons at different times. So that we spoke about delivery systems. So that's really about often it's an API, and often some framework you've got around that. Separating it from your persistence layer, from your database layer, separating it from the API calls that you'll make to other systems, keeping that business logic very central and tight and clean of all of these other external sort of concerns.
Is domain-driven design DDD, is that a clean architecture pattern? Or I thought that was just another pattern.
So I would define DDD as more of an approach to problem solving, as opposed to an architecture pattern or a design pattern. I'd say that they both work very well together. So if you think about DDD and bounded contexts and identifying where these boundaries are, that's going to really help when you're thinking about how you would separate out aspects of or modules of your own system. But even I think it takes it a little bit further with clean architecture when you really are looking at the system level and how you would separate out specific entities, which we can talk about in a minute as well. Separate out your use cases, separate out those things that are core to the problem you're solving versus those that aren't. Whereas DDD is very much, I'd say, an approach to problem solving. We talk about ubiquitous language, we talk about bounded contexts, and both of those I think complement each other really well, which is one of the reasons why I think both of those things together are sort of fundamental ideas that I always try and instill in teams and engineers.
Are domains always so kind of clear cut with having a single responsibility?
No. It's a great question. What I would suggest is domains will evolve, just like everything that we do. Our systems evolve, our approaches evolve because our problems evolve. And when it comes to defining domains and domain boundaries, these two should evolve. So one of the precautionary sort of tales, you think about a real push for microservices, right? And we did go through a phase where monoliths were bad, and microservices were good. And what you found were systems where we couldn't define the boundaries, or the boundaries were blurred, or we were unsure, tended to build systems or result in systems that were really hard to evolve, as opposed to, if I was to look at a problem from scratch, a brand new problem, I would be looking at trying to identify those boundaries. But, that probably wouldn't be a hard boundary to begin with. I'd be more than happy to start with a monolithic system, and you'll find those boundaries over time. And that's the point at which you start to optimize. So again, that should still lend itself towards being able to evolve more quickly. If we make these decisions too early in the design process, we'll build ourselves into a corner. It's harder to evolve from then on.
You talked a lot about building around business rules and separating out like third-party concerns and things like that. I have an understanding of clean architecture, so I'm going to try and avoid talking about things that we haven't mentioned yet. But I'm curious, I feel like it's a related question, is where do you feel things that aren't external, like gateways to other APIs, but aren't specific to a use case, like to a business rule or to an entity, things that end up in utility folders, how do you see those sort of things fitting into the architecture?
Could we maybe come back to that question? I'd like to define what some of those terms are. Maybe that might be an easier place to start. So when we talk about business rules being the center of the application, usually and I should say this language can vary, right? So Uncle Bob introduces a particular language in his book. I know that in teams I've worked with, they've evolved that to create a bit of their own language. So we're just going to use some of that terminology to define what some of these core pieces are. But just know that your teams might call them something different, and you're probably talking about the same thing, and that's okay. But so at the very center, we talk about the picture of, you might have seen a picture of clean architecture being a circle, like a number of concentric circles, like an onion.
That one right in front of us.
The one right in front of Elliot.
That's right. I am holding an onion right now.
At the very center of that is your business rules, and we will often call these entities. So an entity is, you think of it as like a data model for a particular aspect of your system, of your solution. So you might have something like when we work in the monetization team, or a few of us here, so I'll use those as examples because I know them well. But you might have a price entity, an order entity, a product entity. So you think of these things as the core pieces that make up your solution space, and those entities will include the business rules that you will interact with that particular model around. So that's the core. So when we talk about entities, we're really talking about those core data models at the center of our onion. Then built around that is our use cases. So a use case, or Uncle Bob will call them interactors. A use case is hopefully exactly that. It's a use case that you want your system to be able to solve for using those entities. And so that use case might be add a product to an order, or add a discount to this order, or apply this promotional code to this order. Those are use cases. So it's the things your system does to solve a broader problem for your customers or the business.
So would you say that the use cases are kind of like a behavior? So if you were to kind of break it down and think about how you wanted to test your system, you might do it with BDD, where you're saying, look, given an order and given a promo code, when applying promo code to the order, then X should happen. And that we'd have a specific use case or interactor, which is meant to apply that business logic that we're trying to test for our behavior.
Yeah, I would say that is exactly what it does. It models the behavior of your solution. So BDD would be a great approach to understanding and testing those use cases. Exactly. So that's your use case. So your use case, your entities that it interacts with to solve a particular aspect of that problem. And then Seamus also mentioned gateways. So gateways are a gateway to any data or any information that is external to your business rules. So that could be to an API, it could be to the file system, it could be any other way that it's going to. It could be straight to memory. It could be any way that it's interacting with something external to your business rules. So you'll typically use, your interactors will interact. So your use cases, your interactors will interact with the entities and the gateways to solve a particular part of your problem.
So our gateways, they could be to an external API, an external system. They could be to a database. Basically, it's just something external to your use cases, or is it has to be an external system?
It doesn't necessarily have to be an external system. I mean, you could probably argue the file system is not necessarily an external system, or memory. It could just be a Redis cache. It doesn't have to be external, but it's external to your business rules. Your business rules aren't there to persist data, or they shouldn't be. You might have a use case around persisting some particular piece of data. Your business rules are there to solve particular problems based on data that you either have as an input via your delivery system, or via some access to another API or file system.
Yeah, it's less about being an external resource and more about pushing away the things that are prone to change, which often ends up being technology. So if you're storing data in a local SQL database that's part of your code base, it's part of your machine, you'd still use a gateway because maybe you move away from SQL. That technology might become sunset and you have to move away from it. And so the gateways and the adapters are basically creating a layer of abstraction or separation away from your core business.
That was the vibe I was getting there. I feel like you've hit the nail on the head with that word separation, because it sounds like when you're saying, I've got a gateway and that gateway is wrapping something, right? How I'm picturing it is there's an interface basically, right? And I'm thinking interface in terms of C# language, in that I'm defining I can say get order, create order, standard CRUD operations, but I don't know about any of the internals. That's all hidden behind the gateway. So the system could be modular and could replace what was implementing said gateway, and the rest of the system shouldn't change. The interactor shouldn't change. And is this what we mean when we talk about separation of concerns?
Yeah, exactly. These are the building blocks to almost enforce a separation of concerns. So we've talked about separating out external data sources. We've talked about separating out use cases from the data models and the entities themselves. I think just to close off that picture, there's also the application layer. So we talked about delivery system, with delivery system often being an API. You'll be used to probably dealing with systems that have controllers. In clean architecture, there's also the idea of a controller and a presenter, and your controller being the module that will take some input, call a use case, or potentially several use cases, and then map that back to whatever the data structure needs to be for that delivery system. Often via a presenter. So just trying to tie together all the different pieces that should be on that diagram in front of you, Elliot. I don't know if we've covered all of them.
I was told it was an onion.
But that's, again, so what are we doing there? It's, as I said, this builds on patterns that we've seen in the past. So MVC was all about separating presentation. So we have our presenters and our controllers separating out presentation. We've talked about the onion shape. There is an onion architecture by Jeffrey Palermo that talks about direction of dependencies, which we can touch on, but it's aspects of that. Seamus touched on the gateways and ports and adapters from hexagonal architecture. All of these ideas are things that sort of have existed before, and it's sort of bringing them together for good reason, right? They solved important aspects of how we create software. So bringing all these things together, and this is how a lot of those different parts sort of fit together and create that separation. Like it's sort of enforcing that separation, enforcing us to think about if I need an aspect of my solution to do something, it should do one thing, and it's creating a bit of a structure around. Well, if it's interfacing with some data external to our system, then it's a gateway. If it's a core business rule in terms of something we need to solve around a data model, then it's an entity. If I'm responding to an API request, I'm going to have a controller.
Nice. We just talked a little bit about use cases and about starting from that and building around business rules. We talked a little bit about gateways and adapters being like a separation from the things that change in technology. I think you did mention the dependency rule, and I want to dive into that, but maybe let's finish off the onion. Can you describe entities for us? I know that in my experience, there's kind of two classes of thought, but I want to let you describe before I say anything.
I'm interested in what these two classes of thought are. I think, an entity is, I would describe an entity as any aspect of our data model that we need to interact with to solve a particular problem. That's a very broad description, right? I'd also define them as so an entity should have no dependencies. And we go back to the dependency rule. There should be no dependencies. It should just be the business rules, clean and easy logic. It should define all of the ways you would interact with that aspect of the data model. It should be independent, right? As I said, no dependencies. But it should be clear and independent. It should be easily testable. It should be very obvious when something needs to change, like we talked about earlier, like a price entity. Well, it should be, if I need to change some aspect of a price, that's where I should be going. I might also have a tax entity. I might have a discount entity. This is the way I'd break up the model, the solution space. That I've defined it very broadly, but that's what I would say. It's any of those building blocks that my use cases need to interact with to solve a particular part of the problem.
Here we go. Watch Seamus just railroad all of that.
Well, before Seamus gets into that, I just want to, try and clarify things here. So you mentioned a few things. You mentioned entities, but you also mentioned data models. So are those not the same thing?
I should be careful how I define things. I probably should do, yeah. So when I say no, but the reason for that is I've been using that because I feel like it's something that I hope a lot of people can relate to. They'd be used to working with, well, what is a data model? The reason I say no is I don't want to define them as a data. Like often when people say the data model, they'll be thinking about the database or even sort of active models and sort of these sorts of. It's not about that. It's not about the ORM. It's no relationship to our persistence layer. I guess why I describe it that way is I think it's hopefully something people can relate to. But if I was to draw out a solution to a problem, and I'd be drawing all these little boxes of like a price, a tax, order, product, those things are models within my system. Often we'll start by defining them and the data that they contain. And so that's why I've kind of used like a data model. So in my mind, are they the same thing? I'm using them interchangeably, but I wouldn't say they are definitively the same thing. This is not a great answer, I know.
Yeah, for someone coming like out of uni or something like that, where they haven't, experienced years of the verbiage that people interchange to talk about things, it's like on a class you have methods or functions, behaviors, and logic, and then you also have data. You've got primitives like integers, floats, strings. When we talk about data model, it's that aspect of a class. It's the data aspects of a class, not the functions and behavior. And so this kind of comes back into what I was touching on before about the two classes of thought. When you read into clean architecture outside of just Uncle Bob's kind of Bible around it, there's two schools of thought. One is rich entities and one's anemic entities. And that's anemic entities is just data, no behavior. So it's like all the classes just have data and how to access the data. no complexity around business rules or logic or anything like that. We, at least in the space that we work in at SEEK, we work with rich entities. So that is that the entities themselves are more like classes in the sense that the file that holds the data model for a price tells you the interface to all the data as well as exposes a bunch of functions. So in TypeScript, that's just exporting functions from the file. If you were in C# or something, that would be to have a bunch of methods on your price class that lets you do a bunch of common operations.
So that is a great comment there, Seamus. You talk about anemic entities, and let me have a go at maybe defining it again. And I would say an entity is any object. I'm going to call it an object as opposed to a data model. An entity is any object that is required to solve your particular problem. And this is where you could use things like DDD to understand what some of those things are. And I would probably leave it at that, right? Because they don't have to represent a physical aspect of that solution. Like, it doesn't have to be a price or an order or a product. It could be something quite generic around the way you might want to structure your rules, or some particular data structure, right? Could potentially even be an entity. But then when you talk about rich versus anemic, I like the way you defined it. I don't think I've seen too many teams stick to that definition maybe as precisely as you've defined it. Like, I often see people calling them anemic, whilst they still have a richness to them. They've defined it that way because they want it to be as precise, as explicit and as simple as possible, as opposed to a rich entity, which may, like you said, it could involve more logic, more business logic, more the methods and so forth. But if it starts to interact with other entities and start to pollute the space of that entity is when that becomes a problem. So I'm saying lots of things here. Maybe taking another step back from the very start. We might have touched on this previously, but Uncle Bob's book is I think, first of all, I think it's a great read. It's very generic, and it has some criticism around it for saying, well, I don't understand how to put this into practice. In my mind, that's a strength, right? It means that it's not tied to any particular technology, any particular language, any particular solution, right? It helps us, it guides us towards a more evolvable solution without defining what that solution is for us. So it's up to us to interpret how this works best for us and our team. So I should probably start there. Like, it doesn't give you a solution, right? It talks about ways that we should think about defining our solution, to achieve some of these things that we want to really achieve around maintainability and testability and evolvability. So with that in mind, like, I don't think there's any rule around what an entity should look like or should be. So the only rule should be your whole team should understand it and be on the same page.
So if I was to follow up on that thought, that would mean I could be using functional programming and have a file which is, say, the orders entity file. And in that file, I define my order type. But then there's all the methods within that file, which is, say, create order, update order, which kind of like transforms the abstract concepts of an order into an actual object that can be passed around by an interactor and sent to a gateway to, say, be saved to the database. So that file is my entity. It's not literally the order object is the entity. It's the whole conception of creating and modifying that object. Yeah.
So in my interpretation is yes. Like, if I think about the entities are there to define the business rules of our system, it'd be very hard for me to define a business rule without some methods and functions around that.
Right? Okay. And to follow up on that further, just to mentally build this picture for those out there. So we've got this concept of controllers, and you mentioned that really ties well to an API. So if we were putting clean architecture into practice, we might have an API that has a orders controller, and we're just going to assume it supports CRUD operations for argument's sake. So we'd say there's a create order. So we'll have some sort of request coming in, which will hit our controller, which then presumably maps that to our internal definition of this entity. and then something happens with an interactor, and then it ends up getting saved in our database, presumably.
Let's talk through the flow. That's a great idea. I would firstly say that it's probably not an orders controller. Going back to single responsibility and separation of concerns, it might be a create order controller, update order controller. But the flow of information would be you would get a request coming in, probably via HTTP. You would that would come into your controller, as you mentioned. Your controller would map that to I'll say a DTO, so a data transfer object, creating a hard boundary between the external and the internal of our use cases. So first thing it'll do is other than security and authentication and those things that will come, is it will map it to a data model that our system, our use cases, and our internal domain understands. It will send that DTO off to the use case that it wants to execute, which might be create order. That use case, that interactor, would then interact with all of the different entities it needed to achieve that functionality. So, for example, it might map that information into some order object. It then might use a gateway to persist that order. It then might use some other mapper to map it back to a particular response for that controller. So that's what the use case and the interactor would do. It interact with the different entities, and you might be interacting with a price and a tax object and those things to create that order. It would then send that back to your controller via another DTO, response. So we talk about request and response DTOs coming into our use cases, and then our controller would use a presenter to take that response object and present it in whatever way was necessary for that particular delivery mechanism. So it would turn that back into the body of a HTTP response, for example, and then send that back out via our library. And probably one of the key things to call out there, which I think is something that clean architecture helps create some real structure around, is what you often see is, let's just take Node, because it's something that we use very regularly here, and we have our COA framework, is that COA framework should only exist at that controller layer and no further in. We shouldn't be passing COA request and response objects into our systems, because that's when we start to create coupling, and that can create some challenges moving forward. So that would be the flow. So even if we're using a framework, that framework lives at the edge, and then the data will flow through, use our entities, and flow back out through our controller.
So you just touched on something then, talking about, I can't remember what it was, Axios or something like that, COA objects requests, whatever, talking about not letting that bleed into your system. We talked on a little bit, I think it's a good opportunity to talk about the dependency rule and how we maintain, like, what is the dependency rule, and how do we use it to guide our understanding of where certain things should live within the layers and how the layers should interact with each other?
Yeah, so hopefully that brings, if we've painted a picture in our minds of an onion and this data flow flowing in from the edge into the middle and then back out again, what our dependency rule says is that I've got to think of how I define this. The dependency rule says that any module should only depend on Give me a second to think about how I'm going to define this.
In the TypeScript world, the way that I think about it is no layer should import from the layer above. So like entities can only know about other entities, never about use cases. Use cases can know about entities and maybe other use cases, but nothing else. Adapters, gateways to databases and stuff, they know about everything on the application layer and all the way in. So they could refer to an entity. They can basically import anything in the application because they're the things that change and you can throw them away and replace them. But the core things that should never change is like price. How do we apply a discount to a price? Business rules around this country gets a certain tax, this country gets a certain discount, whatever. That should always be core right at the very center and not changing because of external concerns.
Yeah, that is a perfect definition. I was trying to draw a picture in my head with the arrow pointing inwards, which is exactly right. the direction of your dependencies should always face inwards. So an entity should never depend on anything in an outer layer. A use case should never depend on anything other than an entity. Like all of your arrows should be pointing inwards, and that's deliberate to again separate out those things that we are perhaps least certain about. Uncle Bob talks about sort of higher level policies and lower level policies. It's really those things that we are less certain about. We want to push to the edge. And if all our dependencies only point inwards, our entities, the core aspects that implement the value of our system, should not depend on anything else, which makes them easy to test, easy to evolve, easy to evolve independently. Exactly. And our use cases, like you said, use cases would only depend on our entities. So the core domain of our system and our solution is very contained. And then all of those externalities, which can change at different rates, are no longer coupled to the core value that we're providing.
So if we're thinking about it like this, is this the correct approach, or is this the trap to fall into? So we've said there's an order entity that has a price. And if we said we want to apply a discount, right, to that order which has a price, those sound like three entities, but you've got business logic that's going across the three entities. So where does that live? This use case concept, is that a function or a class that we're calling, the apply price discount interactor, because that's going to reference three entities potentially, which is going down, but the entities themselves don't know about the other entities, or they might know about them, and that's fine because they're on the same layer. But this function where we apply this business logic in the use case, that's kind of what I would have thought it is, like applying a discount to an order is business logic, and therefore shouldn't that be at the entity layer and not this in this use case or interactor function?
I think, if I can interject, I think this is where DDD actually helped me inform my understanding of, because Uncle Bob doesn't really give you a lot of detail around like this kind of question. How do you model in entities interacting with other entities, services that aren't quite external but need to do some common stuff but aren't quite an entity? How do you model all this stuff? Oh no, it's happened again. It's always once every recording. Right. So one of the things that the DDD talks about is value objects, entities, and aggregates. And if you apply that thinking to clean architecture, what you end up with is things that have no persistence, no ID, they're just DTOs. They live temporarily just to model the boundary between two things. Then you got entities, they're often persisted. They've probably got IDs and aggregates. And aggregates can be an order might be an aggregate that contains products and prices and other things related to an order. On its own, it doesn't offer any value without other entities. And so when I think about aggregates versus entities, I try to push specific behaviors like applying a discount into price, but then the aggregate is something that would invoke that functionality. So it doesn't contain or own the business rules. It's like a mini use case. It's like orchestrating what the use case is trying to do to it, but in a way that's reusable and shareable. So like if we have three systems within our domain that all rely on prices and recalculating prices, and they all need to apply that same business rule, you could in theory have entities as part of a shared SDK that contain very generic but specific business rules to that entity. And then your aggregates are probably like product set is specific to that domain, order is specific to that domain, but they can share and reuse this common entity behavior.
Who's our guest here today? Is it you? Are you our guest speaker today?
I've spent a lot of time thinking about and talking about. I've probably spent more time thinking and talking about clean architecture and architecture stuff than I have about most other software engineering topics. I've spent a lot of time over the last 6 years picking Adam's brain and getting him to come to my teams and talk about clean architecture. So I've been in this conversation probably a dozen times.
There's just two Adams in here.
I love it.
What I found, and having worked across numerous teams and implemented a lot of the ideas from clean architecture for many years now, is every team has always done it differently. Every team has always evolved those solutions as they've gone. Again, because the reality is, systems and the problem that we're solving continues to change, whether the business changes or pivots or customers evolve their requirements or technologies change, security issues come in, libraries are are updated or even disbanded altogether. There's all of these influences of change that we need to keep evolving towards. And the idea here is really to create a system that is easy to maintain, is cheap to change. So I was on a podcast, and I'm going to quote this poorly, but it was a while ago.
Typical of a podcast, plugging another podcast.
They were talking about architecture being a way to minimize the cost of change whilst maximizing the value it provides to the business or to customers. And that's really what this is about. It's not about defining here's a one solution that fits all. So you're right. You can interpret these things in many different ways. And I've interpreted them in one way, and that doesn't mean that it's correct. And Seamus, as he mentioned, him and I have had many great conversations over the years in terms of how we might implement these things. And that's evolved over time. So, my suggestion to anybody that is thinking about or implementing some of these ideas or is new to it is just to start somewhere and to start simple, right? Define your use cases, define your entities. Don't get caught up in, when I say define, like at a high level, like what are they? Don't get caught up in, where does this particular interface live? Is my use case or my interactor doing too many things? You'll quickly find out. Right, you'll quickly find out when you start writing your tests, if you haven't already written them before you start writing your modules. You'll quickly find out, like if your module is hard to test, then your code's probably not great.
Like the way that I've come to think about it, because I think for a very long time I was trying to create like a skeleton model of like what clean architecture looks like and how but you can't really apply it consistently. I think that, and I've said this a few times before, the most important things are everyone on your team is on the same page with how you do it in your domain. And the second one is understanding the problems that you're trying to solve by applying the architecture, because if you understand those problems, you can see them as you're writing the code. And it's less about where should this live and more about how does this change bleed throughout my code base. So when I'm introducing dependencies, creating wrappers, creating DTOs, whatever, I'm thinking about how does this entity, if I was to change this new thing that I've introduced, how deeply into my system does that change go? How contained is this thing? If I want to change prices, how many modules need to change? If I want to change orders, how many modules need to change? If I've got to change my HTTP client, how many things need to change? And so by not trying to think about a solid structure of what the architecture should look like, but just trying to think about what you're trying to avoid, I find that informs you. So these two things come together.
Can I maybe challenge that thinking in one way and say, why is it about the number of modules you need to change?
Well, I mean, we talked about this the other day. It depends, right? Because if it's a core, like if you're building a products API and you have a core product entity, probably that thing is going to change in a lot of different places. A lot of different test mocks and things like that are going to change. So it's not the best. Like you can't apply it in all cases because entities probably do exist through a lot of layers of your system. But if you're looking at the outer boundaries, like your Axios client, for example, if I was to introduce an entity from an external source, like my system needs to talk to the higher accounts gateway and get a higher account, how much of that model bleeds into my system? Is there some good abstraction layer that separates what I care about from what they've got so that their changes don't bleed into my system? Like if you change the shape of your higher account DTO or your entity, how much of my system has to change as a result?
Yeah, because I think this is one of the potential pitfalls, right? I've seen this many times is people teams have architected their system in a particular way and they've probably got some great levels of abstraction and some really great separation of concerns, and it comes to making changes and they think, oh, hold on, I'm changing too many files here. And I think that's often the wrong metric to really measure the effectiveness of your change on. If there are lots of little simple changes that are very easy to understand, very easy to code review, have very little impact on the overall design of the system, that's not a bad thing. Versus, say, a change where you might only be changing one or two files, but it's tens of lines, hundreds of lines that have changed, and all of your tests are suddenly changing, and you're suddenly seeing tests that you need to change in other modules or other parts of your system. They would be more of the code smells that I would be worried about. But you're right, it's a natural reaction. It's like, oh, I've changed 40 files, but I was only making a really simple change. That probably still is a simple change. I can't help but feel I haven't answered your questions that well. But is there any burning questions that?
It's okay. Seamus has answered them really well. So.
Yeah, I know. It's a challenging topic to. It's a big book, that's based on a whole lot of ideas and experience that has come before it. It's very hard to explain in 45 minutes to an hour.
And like you said, they are general topics. Like it's hard to give specifics on these topics when they are explained generally in the book. So I think you've done a bang on job there.
I think we've done a good job of distilling, maybe a combined 10 plus years of experience down to half an hour, 45 minutes.
Clean architecture is not a silver bullet. It's not going to solve all of your problems.
Why not?
You might have a really simple system that does one thing and is unlikely to change for a very long time. Well, maybe you don't need to add in all the additional layers of abstraction. But typically, systems continue to evolve over time. And, we talked about the article from Martin Fowler, and sort of what the outcome of that is that, quality software is fast. It's a statement. It is quite clear. Hopefully we've all experienced this. We know that we are going to be quicker to deliver value to our customers and to the business with quality software. So actually investing in that quality for any system that's likely to evolve over any reasonable amount of time is almost always worth the effort.
Nice. I feel like that's a really good stepping off point. Music kicks in. It's been great chatting. Nice. I feel like all the things that I would like to, all the things that I think about when I'm talking to people who are new to architecture, new to clean architecture, we've talked about today. So I feel good.
It's, what I've learned from this? It is really hard to explain software patterns and architecture without a whiteboard.
Yep.
Yeah, thank you for coming on.
Thanks, guys.
Please come again.
I would love to.
Let's have an episode about story points where we talk positively about story points. Then maybe we can release
story
that other one.
points.